A water faucet breaks in the physics room, spraying water upwards. If the gauge pressure in the water is in the water mains is 21 psi at velocity is 0, with what speed does the water hit the ceiling 4.8 meters above the faucet? How much time does it take? Duggan had a faucet break and like nobody came to fix it. It's like, okay, so 21 psi divided by 14.7 times 1.013. Let's turn that into Pascal. So 21 divided by 14.7 times 0.013 E5. This is 1.447 times 10 to the 5th pascals. All right, so now we've got this pressure. And what I'm going to do is I'm going to say the gauge pressure in the water mains. Okay, so that's how much it is above the atmosphere, right? So the absolute pressure there is, I'm going to add an atmosphere, 1.013 times 10 to the 5th to get the absolute pressure, plus 1.013 E5. So the absolute pressure inside the water main is 2.46 times 10 to the 5th pascals. So, and it's a very large water main, let's just say, right? Let's say the situation is this. So we got this water down here, right? And it's issuing forth, and the ceiling of the room is like right there. 4.8 meters. That's a 4 meters like that, right? And we want to know what this velocity, we'll call this velocity 2 is, right? Okay, and then we'll say that the water in the pipe is not moving, right? So we go 1/2 rho V1 squared plus rho G H1. I'm going to use H1, I'm sorry about that. Plus P1 is equal to 1/2 rho V1 squared, 2, plus rho GH2 plus P2. Okay. Let's say that the water in the mains is not moving, that it's at no height, and that there's some pressure there. So P1 is equal to 1/2 rho V2 squared plus rho GH2. So there definitely is a height there, right? Plus pressure 2. Okay, we can do this. We can do this. Okay, so this pressure is 2.46 times 10 to the 5th is equal to 1/2 1,000 times V2, and this is what we're trying to find, right? What speed does it hit the ceiling, right? Plus 1,000 times 9.81 times 4.8 plus 1.013 times 10 to the 5th. Now notice that I added that to make this absolute pressure, and then I put that over here, and the very first thing that's going to happen is I'm going to subtract that out. So I really would have been okay saying that there was no pressure here and that this was 21 psi converted into air. So I could have used that number right there. And so you get the hang of that, right? I didn't have to use absolute pressure. I did it just because I thought maybe that would be more clear, but there it is. Okay, so I'm going to take this number. I'm going to subtract 1,000 times 9.81 times 4.8, and then I'm going to subtract 1.013 E5, and I now have what equals 1/2 1,000 V squared, right? So I'm going to multiply it by 2, divide by 1,000, and now I have what equals V squared, and then I'm going to square root that. And I get 13.97. And then here's the hardest part of the problem, right? We have 3 sig figs, so how do you round it to that place, right? Well, the answer is it's about 14.0 meters per second is how fast it hits my ceiling and drips all over.